I know that many of you had questions about the linear transformation homework problem, so I wanted to do another example for you today so that you'd have that for your test tomorrow. I know most of you probably already looked at this, but I just wanted to make sure. So we have a linear transformation problem here. In this problem, we want to let the transformation d, which takes a function y, and that's equal to the derivative of y with respect to x. And we're asked to determine if the transformation d is linear, and we're told that you may use any properties of the derivative you have learned from calculus. So our solution starts by understanding that in order to determine if something is a linear transformation, we must first check the two properties for linear transformations, which are 1, d of y plus z must be equal to d of y plus d of z, and 2, d of alpha times y must equal to alpha times d of y, where alpha is some real number. So we begin checking the first property. We assume we have two functions of x, y, and z, and we look at d of y plus z. This would then be equal to the derivative of y plus z with respect to x, which is equal to the derivative of y with respect to x plus the derivative of z with respect to x, and we know that this is true from calculus. Looking carefully, we know that the derivative of y with respect to x is just what we are calling d of y, and the derivative of z with respect to x would then just be d of z. So it is true that for this particular transformation, d of y plus z is equal to d of y plus d of z. Now we need to check the second property. D of alpha times y is equal to the derivative of alpha y with respect to x. Again, because of calculus, we know that we can pull out the constant alpha, and that's alpha times the quantity, the derivative of y with respect to x. And from above, we see that is equal to alpha times d of y. So the second property also checks out. Therefore, we are able to say that d is a linear transformation. I hope that this helps.